Hello everyone, my name is Shub Patel. My SAP ID is 56, batch B4. I am from third year of electronics. In this experiment, I am going to show how to design a PWM circuit using timer IC 555 on simulation tool LT Spice. So let's move to the block diagram of IC 555. So this is the block diagram of IC 555. We have ground connected to pin 1, VCC supplied to pin 8. Then we are going to provide triggering input signal at pin 2, and at pin 5, which is the control voltage, we are going to provide a modulating signal, and we are going to get our output at pin 3. So basically, to work this IC, that is IC 555, as PWM circuit, we are going to provide high frequency triggering input signal at pin 2, low frequency modulating signal at pin 5, and get the output from pin 3, that is output pin. So let's move to the functional diagram of IC 555, which is the monostable vibrator. The circuit is same. The difference is that the at pin 5 we are going to provide a low frequency modulating signal, and basically the capacitor starts charging to its highest instantaneous value of modulating signal, which is the sinusoidal wave, and as soon as the triggering it, it gets the triggering input, it gets discharged immediately through the ground, which is over here. So let's move to the simulation software tool. So I have already constructed the circuit. So as you can see, at pin 1 we have connected ground, and we are going to provide VCC supply at pin 8, and at pin 2, which is a trigger pin, at that pin we are going to provide a high frequency triggering input signal, as you can see over here. And this is the pin 5, which is the control voltage, and at that voltage you are going to provide a low frequency modulating signal. And at this pin, which is the discharge, and this threshold, we have connected a discharge capacitor, and at this pin, which is the output pin, we are going to get our output. So, and we have connected our reset pin to to VCC, and we have used a resistor of 10 kilo ohms and connected it to VCC. So let's run this circuit. So let me add the plot over here. Let me add one more plot. So let's add traces, uh, trigger in trigger voltage trace, which is of high frequency trigger in input signal. This is the high frequency trigger input signal, and in the second plot we are going to have our modulating signal. As you can see, the time period of this modulating signal is too high, that's why the frequency is very much less. So this is our low frequency modulating signal. Let's add one more trace, which is the capacitor voltage, which is over here. So as you can see, the capacitor starts charging towards the highest maximum instantaneous value of the modulating signal. So basically, when the IC 555 is used as monostable vibrator, the capacitor starts charging towards plus VCC by 3 to VCC by 3, and discharges through this trigger circuit. But in this case, the capacitor starts charging towards the maximum value of the modulating signal. So capacitor starts charging towards the maximum value of the modulating signal, and as soon as the trigger pulse arrives, it immediately discharges, as you can see over here. So in the third plot, let's add the tray, which is output trace. So when the modulating signal increases, the width of this output also increases, and when the signal decreases, the width of this output also decreases. And as you can see, the modulating signal starts at 3 volt and goes up to 4.5 and to down 1.5 volt, which means it is an AC/DC signal. The frequency of this output decreases when the modulating signal increases, and it the frequency of the output increases when the modulating signal decreases, as you can see over here. So thank you for watching my video.